Let's start with the previous slide. So we had this very cheap upper bounding procedure that we need in order to discard some region of the search space that we don't want to explore. And of course, one easy way to find an upper bound is to relax the problem. So by relaxing the problem, it means that we can remove some of the constraints, and by removing some constraints, maybe the problem becomes easier. And for this knapsack problem, we can think about two possible relaxation strategies. So think about it. Actually, we have two constraints here. Okay, we have this constraint, but we also have that constraint. Okay, the fact that xi must be taken on the set 0, 1, which is a binary variable, can also be considered as a constraint. Of course, you can also relax it by assuming that it can take a continuous value between 0 and 1. Okay, so two possible relaxation here. We can relax the capacity constraint, or we can relax the integrality constraint. Let's relax first this constraint, which is the capacity constraint. We assume that we don't have the capacity constraint. So here I will assume that I'm exploring the search tree in a depth first search way. Okay. Just to make sure that we are on the same page. Depth first search means that I'm exploring this node 1, 2, 3, okay, then you backtrack 4, 5, 6 will be there, and then 8, 9, 10, 11. Okay, that's depth first search. But I'm sure that you are already familiar with this. What I will represent here is the state of the node. Here you've got the value that you have accumulated so far by the previous decision in the ancestor nodes. You have the space left. You've got the upper bounding procedure. Okay. In that case, it will be assumed that it's obtained by relaxing this constraint. We just get rid of the capacity constraint, and we have the best known solution so far. Okay. So initially, the capacity here is 9. The upper bound is 78 that you can obtain here. So we don't take this constraint into account. So you simply assume that you can take all the items without any limits. So 28 plus 30 plus 20, okay? And you've got here 78. And you've got the capacity. Of course, you don't have a feasible solution yet. So it's still unknown, the best known solution, okay? And then you go to the left because we are exploring in the depth first shot, and you take the item 1. We select it. So if you select it, obviously the capacity is now reduced to 5, because you see that this item was taking a space of 4. So the capacity now is 5. And the upper bound didn't change, okay? You still can take this one and this one, okay? And you know that you have already taken the 28 for sure, okay? Then you go to the left and you select the second one as well, which has a weight of 6. And so here, I'm putting it in red, okay, to indicate that this node is in violation with respect to the capacity, okay? Of course, we relax the capacity to compute the upper bound, but since we're interested to find the best feasible solution, it must be feasible, we will also discard nodes that are proven to be unfeasible, and this is the case of that node, okay? So we need to backtrack in depth first search, and we go there. We unselect the item 2, okay? We unselect the item 2, and these two decisions now cannot be reconsidered, okay? We take the item 1, we do not take the item 2. If we go to the left, because we are doing depth first search, okay, this node is feasible now. It's feasible, and it means that I've got at least one feasible solution, which now is 48. I backtrack, I do not select that one, and here it's also feasible, but it's dominated, right? It's dominated because the best feasible solution, okay, here is 28, okay? I don't have any other choice left, so I've got a solution with 28, which is less than 48. So this node is dominated, this is why it's put in orange. Then we backtrack up to the root and we go to the right, okay? We do not select item 0, but the upper bound, if I have a subproblem in which I cannot take item 0, is 30 plus 20, which is 50, okay? 50 compared to 48, okay. If I'm optimistic, it means that I can still improve my best known solution by at least 2 units. So I need to continue. I continue, I go to the left. I select item 2, okay? and it's still 50. Okay, it's still 50. It's still unclear if it leads to a best solution or not. So I go to the left, and this one is unfeasible. Okay, it's unfeasible. I've got negative capacity left, so it's unfeasible. I go to the right, and this one is dominated. 30 is less than 48. Okay, I go to the right here, and here it's also interesting because the best known solution, if I cannot select the best upper bound, if I cannot select 0 and cannot select x2, it means that if I'm optimistic, I'll only have 20 left. And 20 is worse than the best known solution, which is 48. So I can stop here. I can prune this region. I don't need to explore that part. I know that it will be, it's not promising to go there because I cannot improve my best known solution. Okay? Of course, I have used a depth first search strategy. I could have used another search strategy to explore the search tree. I will come back to that later.